I'm Tim Wagner. I'm the General Manager for AWS Lambda and Amazon API Gateway. And we're really delighted to be here with you today, sharing all these amazing customer stories about this topic that's so near and dear to my heart, serverless architectures. And, it looks like there are a few servers up here on stage. Now, I don't think it's right to have a serverless State of the Union address if there are going to be servers on stage. This happened in New York, and we had to get out a baseball bat to take care of them. And then it happened again in Tokyo, and we took a sword to them. But here we are in Vegas, at the Mirage. I think what we need to get rid of these servers is a little bit of magic. Always good to get rid of some servers while you're at it. Of course, the real magic is the amazing power that serverless brings to developer productivity, cost savings, and making it really easy for customers to deliver more value to their businesses and for their customers faster than ever. So we're going to talk about a few things here this morning. For those of you who may not yet have joined us in the serverless revolution, I'm going to bring you up to speed a little bit on Lambda by talking about why we developed it and kind of how we think of it in sort of the evolution of compute. Then we're going to take a look at how customers are achieving faster time to market, lower costs, and more business results by adopting serverless solutions. And I'm going to be joined up here on stage by Tim Griesbach from FINRA. And he's going to tell you a little bit about their serverless journey and some of the things that they've discovered along the way. And then finally, we're going to dig in a little bit to some of the great new features that you've heard about being launched this week. And we'll see how Lambda fits into an entire suite of serverless pieces from AWS, a whole portfolio of which is designed to keep infrastructure out of your way while making your job as a developer easy, fast, and fun. So what is serverless? Serverless computing lets you build and run applications without thinking about servers. Of course, your application still runs on servers, but the server management is done by AWS. You no longer have to provision, scale, or maintain those servers. You don't have to install and operate databases. You don't have to think about storage systems. The complexity of managing authentication and connections for mobile and IoT apps, all of that infrastructure complexity goes away with the serverless approach. That care and feeding of the infrastructure, everything from security updates to new hardware migration becomes our responsibility instead of yours. And it's not just the hardware infrastructure that you get to stop worrying about. It's also the software servers. It's also the responsibility of receiving all those requests and then having to wait around and figure out what to do with them. With this approach, with Lambda, instead, we call your code only when it's needed, only when there's something for it to do, which can also save you a lot of money. Now let's take a look at what led up to the creation of Lambda. So the modern era of computing has gone through several phases, with each era shaping the ecosystem and the software that was dictated by that hardware. So, go back 15, 20 years in the realm of physical servers in data centers. An expensive data center proposition required in order to get started building a business and sometimes even just building a new application. Now, as an industry, we made that a little more efficient in the virtualization era because we could pack more work onto an individual box, and it was also the beginning of a journey to separate the software and the code from some of the ties to particular pieces of silicon on which it ran. Of course, it was still sitting in a data center that you had to own and operate. So moving to the cloud was our next major revolution. It freed companies from the physical limitations of operating their own data centers. It achieved that economy of scale so that one HVAC and power plant could service many different companies. And it started that journey of moving even more of the management away from individual companies and over to a service provider. But still, that server-by-server programming model and all the operational and deployment mechanisms associated with it were still inherited from previous generations. Now, each progressive step here got better. Virtualization improved utilization, gave us faster provisioning and speed, disaster recovery, some of that hardware independence. Then the move to the cloud capitalized on that trend, turning those lengthy and expensive data center investments into simple, fast, and flexible cloud provisioning of infrastructure. And it furthered that important process of shifting the maintenance burden from the application owner to the cloud service provider. More scale, more elastic resources, and of course, much more agility as an organization. But even in the cloud, there's still limitations to infrastructure. You still have to administer those servers even if they're virtual, even if they're in the cloud. You still need to manage the capacity and the utilization, and size the utilization and the capacity to your workloads. You need to be able to have enough capacity to provision for your peak experience, while still worrying about carrying too much when you might be idle. And then under-provisioning can lead, of course, to outages. And then, of course, there's the challenge of managing all those fleets of servers, ensuring that you have the right bits on the right machines at the right time. And this is what led to the evolution that brought us to Lambda. We wanted to meet not just current, but future IT needs, to help companies be as agile as possible, and to take the parts that they told us were the most challenging and often the least differentiated and least interesting for them out of this particular puzzle. And the answer to that was Lambda, our serverless compute solution that has all the benefits and compute power of existing cloud infrastructure, but without the operational complexities of dealing with the servers themselves, or of getting applications onto those fleets of servers. Both the hardware and the software models get easier in this next generation of compute. And the challenges, the responsibilities that were endemic to owning the infrastructure, even virtualized cloud infrastructure, go away. Worrying about whether you're using servers effectively, building distributed infrastructure to handle fault tolerance, dealing with scaling, getting code onto the machine, all of that disappears by virtue of transferring to AWS. And with that, you can focus on your business logic instead of where and how that logic runs. For example, recent security patches like Dirty Cow, hardware migrations to newer generations of machines, and routine machine maintenance and cycling are all handled by the Lambda team. Lambda developers, on the other hand, don't have to think about those problems. So we've talked a little bit about what serverless isn't. Let's talk a little bit about what serverless is. Lambda helps you respond to events in real time. Now, there are a lot of ways you can build event-based systems, of course, but this particular approach offers the simplest and fastest way to construct reactive systems, webhooks, and other kinds of asynchronous processing models because it alleviates the challenge and the conventional hassles that are associated with trying to match and scale capacity to an unpredictable workload. When there's nothing to do, you typically have too many machines. When there's a lot to do, you often have too few machines. And with Lambda, that burst capacity is built right into the system so that it can react quickly and efficiently and is able to monitor along the way. That continuous scaling is super important. It's a key piece of what makes Lambda Lambda and differentiates it from infrastructure mechanisms. Because scaling happens per request. Lambda accepts and monitors each request on your behalf. So it can scale up and down, it can place your code in the right place, and as a result, you get these really interesting benefits. For example, it lets us replace hardware as we need to. It lets us do fault tolerance on your behalf because we can place it into the right availability zones. And it helps us monitor your application so that some of this sort of annoying grunt work of just building basic, simple kinds of monitoring and logging isn't a challenge that your application developers have to deal with. And then finally, you don't have to think about the deployments and the code runtimes at the machine level. You're not renting the machine. You only pay when your code has something to do, when we give it some work to do. And importantly, when you're not running, you're not paying. That whole concept of being over-provisioned goes away. Now, Lambda is the compute portion of what is actually a large portfolio of serverless offerings from AWS. All of these services together help you build application architectures that enjoy the same kind of benefits that Lambda provides for compute. Object storage in S3, where you don't have to think about where the capacity comes from. NoSQL data storage in DynamoDB. Real-time streaming with Kinesis. And as we'll discuss, a couple of important newcomers here as well that you heard about this morning. Now, all of these services have a common goal: speeding up the innovation and delivery flywheel for your application and your business. Removing the friction of thinking about compute, storage, and networking infrastructure takes away whole categories of operational complexity. For example, with Lambda, code deployments to the fleet are the responsibility of the service. With S3, allocating and provisioning additional storage for the files, the responsibility of the service. Now, this operational benefit creates a developer productivity effect because you don't have to write the code to do those things. The code that you might otherwise have had to supply as part of your application never appears. And your developers, freed from the responsibility of doing all of that grunt work for monitoring and logging and capacity management and fleet deployments, can instead spend their time on the business logic, speeding up the delivery of the things that you actually care about, the things that actually differentiate your business. And of course, the idea is to free you up to do more time, give you more time back for innovating, differentiating, and competing in an incredibly and increasingly agile and competitive market. It's a powerful cycle, and one that we've seen many times as companies start to adopt a serverless architecture. So, we've talked a little bit about what serverless is, how we came to be, and how it can help improve productivity, lower costs, and decrease some of your operational burdens. Now I want to take a look at how actual customers are using Lambda today and how they're using the entire AWS serverless portfolio to out-innovate their competitors and deliver business results. I want to start by looking at some of the common categories that we see people using serverless for. And we'll start with web applications. From simple, static websites hosted on S3 to fully dynamic web apps that utilize Lambda, Cognito, DynamoDB, and others, customers are increasingly choosing serverless approaches for doing this job. And the reason's really simple. Zero code when you don't have customers using the site, and then almost instantaneous scale-up when you've got a flash sale or a sudden burst or you've released a new product or whatever it is that triggers usage of your website. That can be incredibly difficult to plan for and incredibly difficult to pay for with a conventional mechanism. And so serverless is ideally tuned to that. And to make building these serverless web apps even easier, we've also recently released open source implementations of both Express and Flask, the latter with our Chalice support, that makes it even easier to use API Gateway and Lambda with these common web application frameworks. Now, of course, it's not just web apps that you can build this way. Backends for mobile applications by using the mobile SDK along with Cognito for authorization. Combining the AWS IoT service so that you can reach out to connected devices and build backends for them as well, including being able to run native code, which is often required to make that work in the cloud. That same paradigm and some of those same benefits, developer agility, productivity, easy scaling, all apply regardless of what type of backend you're creating. Now, in the middle and kind of the linchpin here is data processing. And this is what we first launched Lambda supporting, and it is still one of the largest parts of our business today, hooking up to these incredibly big data pipes that come from S3, so you can have a Lambda function react when an object's uploaded, to DynamoDB so that you can react when a database records change, to Kinesis so you can do clickstream analytics and other kinds of real-time streaming. These are all amazingly dense compute workloads that are ideally designed for a reactive and serverless approach. And they work really easily by simply combining Lambda with these other parts of the AWS portfolio. And then finally, some of our newer services here, Amazon Alexa and chatbots. You heard about Amazon Lex here today. Powering voice-enabled and language understanding apps, and acting, in the case of Lambda, as essentially a universal webhook receiver. Because the easiest way to build a webhook is with Lambda. And it's the perfect way to run your business logic in response to these services that can have incredibly varied UI on the front end. Now, lots of different customers have already joined us on this serverless journey, using Lambda and API Gateway for purposes of cost reduction, increased agility, developer productivity, or in many cases, even getting things to market faster and easier. Successful startups like AdRoll and Localytics, to Fortune 500 companies like Coca-Cola, to global enterprises like Thomson Reuters, companies of all sizes, all shapes, across all industries have adopted serverless approaches. Let's take an in-depth look at a few of these. Thomson Reuters processes 4,000 requests per second on Lambda, using that to drive information exchange and analytics within their systems. You'll hear from another Tim, who will be joining me on stage here in a little bit, about FINRA, who processes 500 billion validations of stock trades daily. Hearst will be joining us later this afternoon, reduced their time to ingest and process data for their analytics pipeline by 97%, going from processes that took hours to do in batch down to minutes with a serverless and near real-time approach. Vive has used the capacity capability of Lambda to handle massive spikes in their usage that arise when they launch new content, things that would require them to otherwise hold on to huge amounts of capacity that they don't need in slack times. And Expedia, which has used Lambda for both their DevOps solutions and for the generation of their traveler profiles, performs more than 1.2 billion Lambda requests every month. They also do more than 3 million code deployments every month at a cost of less than $1. Now I want to take a minute and look a little deeper at Vivo's use case here. Vivo is a great example of an all-in serverless approach. Their content services are a core part of their business. It's what allows their music artists to deliver video to their audiences and to their partners. So that includes artist and video metadata, video ingestion, video encoding, publishing to their own partners, their own platforms, as well as their partners' platforms, and providing APIs for a variety of client applications. Now, managing all of that the old-fashioned way made it much harder for them to deliver and innovate quickly. They were getting stuck in the IT quagmire. So they opted for a microservices approach. They completely re-architected from the ground up to give themselves the agility, the cost savings, and the burst capacity that they needed in order to make their business a success. And so they completely recreated their data and content platform, building it on top of Lambda, Kinesis, DynamoDB, S3, and Redshift. And now that they don't have to manage that infrastructure any longer, they're free to focus on their business and their customer deliveries and their partner execution. All right, instead of telling you the story of FINRA, I'm going to invite Tim Griesbach up on stage with me. Tim's the senior director at FINRA, and he's going to tell you a little bit about their journey to the serverless architecture. Thanks.
Thank you, Tim. So we're here today to talk about how we use serverless to perform 500 billion data validations a day. It's a big problem we have to solve, and Lambda has helped us a lot. So first, just to understand a little bit about who we are. So FINRA is the Financial Industry Regulatory Authority, and we monitor 99% of all trading in US listed equities to provide investor protection and identify fraudulent activity. Some of you may have heard of things like insider trading, and these are the types of things that we're trying to look out for to try to help you. But this requires data, and lots of data. We receive the market data from the exchanges and the broker-dealers every day, sometimes up to 75 billion records a day. The first thing we have to do with that data is we have to validate it. It's critical. They're required to provide us data, and so we have an obligation to make sure the data is correct and provide feedback to them so that they can correct it and get it to us. It's important. It's really critical that we have clean data that we can do analytics on. So once we get the data and we validate it, then we do what we call market reconstruction. We take and we stitch the data together, and this is to understand the life cycle of these trades so that we can perform various surveillance algorithms and analytics. So that's what it starts with there. So 500 billion validations. This is a lot of data, and this is on an average day. We are impacted heavily by by markets, things that are going on around the world, and sometimes this can spike to 2 or 3 times this number. So just to put it in perspective, what's 500 billion? You know, we talk millions and billions. So if you had a Lego, I think a lot of people out here probably grew up with Legos. If you took 500 billion Legos and stacked them up end to end, it would go around the world 500 times. So it just gives you a sense of how much data we're dealing with. But it's more than just the validation, the 500 billion validations. Our volume varies daily, and it can even vary hourly. If something happens like Brexit or something with Greece around the world, this can drive a lot of volatility in the market. And so we have to be prepared for it. We won't know this in advance, and we have to be prepared to handle it. Also, the rules continue to change, the things that we're looking for. So when we get the data, we have to be able to continue to expand what the validations that we're looking for. Today, we perform over 200 individual validations. We generate about 100 different derivations on the data, and this is as the data is coming in before it's even handed off. And yet, the SLA expectations never change. And so what that means is we're requiring folks to give us the data. We have an obligation to give them back feedback so that they can then correct it and get it back to us. Otherwise, there can be penalties to these folks. So this is very important that we have an obligation to do that. So originally, we did this on-prem with a big Hadoop cluster, like many of you are familiar with that. It's a static cluster, process the files in batches, required to be up and running 24 hours a day, 5 days a week. We leveraged a map-only job. So the files would come in through FTP, they would land on a NAS device, we would pull the files in, perform the validations, generate various error files, things of that nature, and then hand them off downstream. I'm sure many of you have seen a picture like this before. So this created a number of challenges, not easily scalable. This is a big one. If you're going to have a static cluster, you're going to have to size it for scale. So we would have a cluster that was sitting idle over 50% of the time. Well, that was very expensive. In addition, the ongoing server and software maintenance, as Tim just mentioned. You know, we would have the case where all of a sudden there's an emergency issue with an operating system and we need to roll out patches across hundreds or thousands of servers. That's very costly when you're dealing with a system that's running 24 hours a day. And it was also originally designed for batch processing. So in thinking about this new architecture, we set out with some goals that we thought were very lofty. Number one, we want to support any volume spike on demand. We can't predict what's going to happen and when it's going to happen, so we have to be ready for it. We want to get out of the infrastructure management. As I like to tell our colleagues, managing infrastructures should be a thing of the past for us service providers that are building software. Why should I have to worry about that? I don't want to pay for peak volume all the time. I want to pay for what we're using and when we're using it. And then lastly, as part of our regulatory obligation, we want to improve the availability of the data internally. Our goal is to make sure we get the data and hand it off as fast as we can so that folks can do their analysis. So we set out to look at various technologies. This is kind of a standard process, right? We defined the criteria. We cared about scalability, cared about security, data partitioning, how well it could be monitored, performance, cost, maintenance. These were the factors that were important to us. We looked at several technologies, Lambda, we looked at Apache Ignite on EC2 and Spark on EMR. And we performed actual POCs on each of these because we needed to understand how well it would perform. And given our output of that, we found that Lambda was going to provide us the best solution across all of those criteria for this serverless cloud solution. So let's look a little bit about what it looked like. So we ended up, our new architecture is a Lambda-centered, what we call a Lambda-centered AWS solution. So the validator itself is Java code that runs in Lambdas. And so that's where we actually do the various validations. We leverage queues, SQS queues between the components. So as notifications, status messages, things of that nature are flowing between them. We also built a controller that manages the data feed. So it becomes like a little ecosystem of its own. And there's times, maybe reference data changes, where we need to be able to pause what we're doing and correct something and continue processing. So we did have to build that, and we'll talk about that in a minute. Ideally, we'll be able to get rid of that soon, too. And then all of our data, if you've heard some of our earlier talks, we like to separate compute and storage. So all of our data resides on S3, and we manage that in our open source herd data management system. So this interacts with that system as well. So how did it work out for us? This is the neat part. So faster, cheaper, and more scalable. So at the end of the day, we've reduced our cost by over 50%. This has been a big savings, and we can track it daily, even hourly. We know exactly how much we're spending. Processing times. So the ask of me from our management was, we want the data available in less than a minute, no matter when it comes and what the volume is. Errors are handled on a finer grain basis. So again, when you're building batch systems, generally if an error occurs, the entire batch has to get set aside and reprocessed. We've had in the past year several days, so Brexit was one, there have been some others where the volume just spikes. And a spike for us is a big spike. And yet we're able to handle that processing without any issues. And that's been very successful. Less infrastructure to manage. I'm excited for the day that I no longer have to hear from security saying, hey, you need to rush this patch out onto the operating system. I think many of you can appreciate that. But there's another thing that's changed here, and it kind of tied me back to what I guess Werner said during this morning about agility with development. So suppose we're dealing with 500 billion. Suppose we want to test, 10 times that, 5 trillion validations. How do you do that if you're not using serverless computing? You've got to go acquire 10,000 servers, whatever the number may be. Well, here we can take our time and have our engineers focus on the actual value in the software, building data validation tools, data generation tools, and then they can just pump it through the system. And then the framework, the Lambda framework, it scales up, and we can test and see how much we do. So we've got a great deal of success with this, and it's really allowed us to focus more on building the software and not worrying about infrastructure management. So where do we go from here? So the first bullet here, as you probably saw when I said that, the controller, I want that gone. Ideally, with some of the new things they're announcing, we're going to be able to hopefully eliminate that in the next year, so we'll be 100% serverless. Well, now that we understand it, and not only understand Lambda, but also the programming model. This is a different model. We're in kind of a revolution in the software space right now. And this changes how you think about software. So now we're looking at how we can do this for our ETL processes, how we can even replace our web apps, as he's mentioned. Really try to look at new ways to build software using Lambda. And then the last one is really achieve our goal of continuing the push to provide near real-time throughput. And that's really about what our mission is, and that is how can we better protect investors. So in order to do that, we need to be able to handle the capacity and validate the data as quickly as possible. So that's it. That's what we're doing with Lambda. Thank you, Tim.
Thank you so much, Tim.
Yeah.
Really appreciate it. It's incredibly exciting to see a company like this that's getting so much value out of the serverless architecture and really experiencing kind of what it means to inject that into one of the core critical parts of their business. So thank you so much for sharing your stories with us today. So 2 years ago, we introduced you to Lambda. Last year, we told you about how we'd made it ready for enterprises to start adopting it. This year, increasingly, you are telling us about Lambda, how it's become a core part of the way you build modern, responsive applications and drive value through your businesses. We're humbled and very excited at the incredibly fast adoption by companies of all sizes and startups, enterprises alike, and how quickly this has gone from a new idea to being a standard part of the cloud toolbox for so many of you. Now I want to turn and talk a little bit, having kind of considered some of the history of serverless and seen how companies are adopting it, and take a look at the broader portfolio of serverless capabilities within AWS. I want to talk a little bit about some of the new launches that you've heard over the last couple of weeks and up to and including this morning, and see how that fits into this sort of broader space of serverless offerings from AWS. Now, the platform that we provide has a whole bunch of serverless pieces that I showed you earlier. But there's also the idea of capabilities that you need to make a serverless platform successful. Here at Amazon, we're incredibly focused on customer feedback, and we use that to drive our product roadmaps. In fact, over 90% of the features that we work on in Lambda come from discussions and meetings and presentations just like this, where you tell us the things that you most want to see. But we also categorize these investments for serverless because we're trying to build a new way of doing things. And these 9 pieces are how we think about the investments that we're making. And I want to step through each one of these and talk a little bit as we dive in about what we're doing in that area. So I'm going to start off with the cloud logic layer. Computing is the keystone of the serverless platform. And for AWS, Lambda is the central hub that receives events, processes them, and makes calls to other AWS services, including third-party services. And if Lambda is the implementation, API Gateway is the interface, offering fully managed APIs with fine-grained usage and throttling access controls. And I want to talk a little bit about some of the new features that we're building into these components. So as you heard earlier this morning, today we're launching support for C#. We're really excited to be able to add another language to the Lambda platform here. And we've heard from a lot of enterprises who are using C# in their day-to-day business and really want to be able to keep working in a language that they love. And so what we've done with the new introduction of Core CLR is ported that to Amazon Linux and then exposed it in Lambda as a first-class language, with all the same logging, metric support, serialization of common AWS event objects that you'd come to expect from languages inside of Lambda. But we've also tried to make it feel very idiomatic for C# programmers. So support for NuGet and integration with Visual Studio so that you can do all of the development opportunities and experiences that you're used to. Now, over on the gateway side, one of the things that we did as we started releasing features in the run-up to reInvent here was added support for binary encoding. We've heard from lots of customers that they want to be able to process audio files, visual files, other kinds of binary formats. And now they have a simple and natural way to do that inside of API Gateway. We also made it easy to automatically convert to and from JSON. So if you're using Lambda on the back end for your API, it integrates seamlessly with this binary encoding support at the API level. Now, regardless of whether the consumer of an API is external or internal, high-quality documentation is essential for helping that API get used appropriately, correctly, and successfully. And so we're really excited today to be adding documentation support to API Gateway. Now, we've always supported Swagger as a portable way to do import and export of APIs, but documentation had been a missing piece of that puzzle. So now with today's launch, we have full fidelity Swagger documentation support as well. Now, when we set out to do this, one of the things customers told us was a common pain point was the fact that they often had repetitive pieces of their documentation in APIs, many copies of error strings, repeated parameters, and so forth. And so we've also introduced a very simple inheritance model to make it easier for you to sort of write that documentation string once and then have it percolate to all the different parts of the API where it applies. So there's less work to do. You can still export it as Swagger and round trip it back in as an extension, or you can choose to convert it to a standard format on export. Now, you heard in the keynotes about Amazon Lex, this exciting new introduction for natural language recognition and understanding. And Lex is a great example of how we continue to add core capabilities in the form of new services that are integrated with Lambda. In this case, a fully serverless mechanism for text and speech understanding. So similar to an Alexa skill, you can give sample utterances and indicate the parts that you need to be filled out. Lex will go and build a model for those. And then when it's actually supplied with speech from a human actor, it'll interpret that, fill in the missing parts, potentially query back to get pieces of information that haven't yet been supplied. And once it has everything that it needs, similar to an Alexa skill, it'll turn that into a JSON package and call your Lambda function. So Lambda is essentially acting as a business logic webhook receiver to Lex, making it really easy to take that JSON package and then go call out to enterprise connectors or do whatever it is you need to do to make a chatbot or a speech recognition system or some other kind of natural language platform to do the appropriate action. So with Lex, your Lambda functions now have access to the full power of natural language understanding, and you can add speech and text recognition to your Lambda functions. Now, part of what makes that Lambda programming model so easy is that it does fit really naturally into both event processing and other kinds of extensibility roles, both for AWS services like Lex, but also with third-party services. And we continue to invest in tying the platform together in terms of making that integration super easy. We've made those common patterns of computing especially easy to set up. So you can put an object to S3, trigger a function. Put a record in a database to Dynamo, trigger a function. Put a record into Kinesis, trigger a function. And without the need to manage infrastructure, these cloud-native, fully serverless design patterns are super easy to discover, develop, and own. And recently, we've added support for SQL database triggers as well. So now with Aurora, you can actually use a SQL database and kick off Lambda functions as you need to. So you get the ability to do stored procedures in the cloud. And this week, we also announced that Amazon Kinesis Firehose is going to have support for Lambda, bringing one of our most scalable data ingestion services and our most scalable compute service together to form a seamless package that can transform, aggregate, audit, and do other kinds of data analysis as you stream it in and route to S3, Elasticsearch, or other backends. Now, in addition to event processing, we also use Lambda in a couple of other ways. We use it as a customization engine for services like Amazon Cognito and AWS Config. And we also use it in that webhook receiver style for Lex and Alexa and others. And that pattern is also super popular with third parties. So integrating with Slack for commands, integrating with Twilio for message commands. The easiest webhook receiver is a Lambda function. Now, serverless architectures help you simplify development, deliver more quickly, lower costs. But in addition to creating and managing those applications, many of you have asked us for a mechanism to monetize those APIs and Lambda functions as well. And so, today we are announcing that Amazon API Gateway has been integrated into the AWS Marketplace. The AWS Marketplace lists over 3,500 software listings today across 35 product categories. And we recently announced support for API products. Now, with today's launch, sellers can use API Gateway, the easiest way to host and manage their APIs, and publish those APIs directly into the AWS Marketplace. And this is a win in both directions. The Marketplace gives you an easy way to help your consumers, the people who are going to go buy those APIs, discover and purchase them. And as a seller, we've done the hard work for you of integrating billing on the back end. So as consumers use your APIs, we automatically detect that usage, do all the metering, package up the billing information, and deliver it to the buyer as part of their monthly AWS bill. So you don't have to write any lines of code at all to make that happen. And we're really excited to announce that customers are already adopting this. With this week's launch, NTT Docomo and F-Secure have both taken their APIs and API gateway and added them to the AWS Marketplace, providing secure URL checking in the form of F-Secure and speech recognition APIs from Docomo. So we know that these are going to just be the first of many. And of course, if you've got a Lambda function, then you've been thinking, gee, it'd be really nice to make some money from this thing that I built. Add an API to it, and now you can monetize that as part of the marketplace integration. Now, with serverless approaches like Lambda, customers have a deeper relationship with us when it comes to handling the care and feeding of their events. And that means that sometimes those events, even in the presence of a coding error or some other kind of problem, might be really important. And it might be necessary to ensure that that event, one way or another, gets preserved. And so today we're launching a new capability in Lambda to make it even easier to build reliable end-to-end solutions, a dead letter queue, or DLQ, for events. So now when you turn this feature on, any problem that happens in processing your asynchronous events, whether it's a misconfigured IAM permission or a bug in your code or just an input that you weren't expecting and couldn't process correctly for some reason, maybe it threw an exception, will be automatically detected by Lambda. And then instead of giving up after we've tried your code 3 times, we'll take that event and we'll send it to your choice of either an SQS queue or an SNS topic. And probably a few of you out there are thinking, but wouldn't it be nice if I could actually react to it with another Lambda function? And of course, you can take that SNS topic and immediately direct it back to another Lambda function that you use as an error handler. So from there, you can build any code that you want to take action on that failed event. So full fidelity on the payload allows you to capture it, no bits lost, many nines of reliability in terms of being able to preserve and protect those events once they've entered our system. So if you've got data that's coming through S3, through SNS, or other event sources now, you can have very high reliability in the entire end-to-end system with nothing more complicated than giving us the ARN of an SQS queue. Now, customers have increasingly adopted Lambda functions as a way to create decoupled, independently scaled microservices. In fact, one of the great things about Lambda is that it makes it hard not to adopt some of those best design patterns in building the microservices. These smaller, more separate components, single source solutions for each individual function, it's a really nice way to think about application development. And that's great in so many ways. But it does mean that as you start producing more functions that make up kind of a conceptual application, as you start having more microservice applications, you've got more and more of these little pieces. How do we bring back some organization to that approach? How do we keep all those small pieces organized without going back to the problems that monolithic applications were plagued with in the first place? And our answer to that is a squirrel. So this is SAM. In addition to being our awesome mascot, SAM stands for the Serverless Application Model. And what this SAM model is a standard way of talking about and describing a serverless application. All the different pieces, the functions, the APIs, the event sources, the data stores that go into making that up. It doesn't change what those pieces are. So you can still version, update, change an individual function. But now you have a way of talking about the group, about the collection of it in a sensible way, and in a way that we can also use, as we'll see here, for programmatic purposes. And our chief goal with this was to simplify development and management for serverless applications, not just within AWS, but also more broadly. SAM brings order to these different parts of the microservice. And now we can take that mechanism, that representation, and use it to inform things like building, packaging, deployment, and others. SAM is, as of today, natively supported by AWS CloudFormation. So those of you who are language wonks, you can think of this as essentially a new grammar that CloudFormation speaks, so that you can write in a highly tailored, very customized pattern for serverless applications. Makes it easy for both humans and machines to understand the different parts without getting bogged down in infrastructure detail. So we're doing the same thing at the configuration and modeling level that we think we've achieved with Lambda as a service. You can also export any function as a SAM template. That includes blueprints in the Lambda console, making it really easy to get started. And we're offering command line tools to be able to package and deploy Lambda functions now and broader applications using SAM. And then finally, but maybe most importantly of all, we've also made SAM available as an open specification. So you can go to GitHub and download SAM yourself, take a look at it. And our goal with this is to really be able to broaden the idea of modeling serverless apps to the entire ecosystem. So that instead of every individual open source project or partner having a different way of talking about the bits and pieces that go together, we have one common universal way of representing that, in a similar way to which Swagger gives us a common language and mechanism for talking about APIs. Now let's talk about what SAM can do for us when it comes to building serverless applications. Many of you have told us, many of you have told me, that one of the biggest sources of friction in trying to adopt Lambda and serverless approaches has been the absence of a CI/CD toolchain from AWS, particularly one that was tailored well for serverless apps. So today I'm happy to announce that we've got all the pieces in place to make this easy. So using SAM, you can now describe the different parts of your serverless application. You can commit your code to GitHub or code commit. And with the help of Code Pipeline, we can automatically detect that push and then extract your code and insert it into the pipeline to kick off the process. From there, our newly announced service, Code Build, can do the building and packaging of your serverless application. And those of you who've been frustrated by the need to include all of your third-party Python and Node libraries, Code Build can now do the pipping and NPMing for you. So no need to manually package those libraries anymore. Of course, you can test. You can do as many gates as you want there in terms of determining when that pipeline should proceed in various ways. And then when you're ready to deploy, whether it's to test or staging or production, Code Pipeline will automatically integrate with CloudFormation, and it'll use that SAM model in order to either create your resources for the first time, or if they already exist, to go out and update them. So Code Pipeline gives you this mechanism to orchestrate and automate all of those steps, providing a complete end-to-end solution for building, packaging, and deploying serverless applications based on SAM. He's quite the useful squirrel. So now you've built and deployed. The other question we hear a lot is, but how do I diagnose it? You've given me this thing that's got lots of little pieces. It spans lots of services. Maybe it spans lots of APIs. I've got events, and they're flowing all over the place. How do I understand that topology? How do I get my head wrapped around what's going wrong when something doesn't work? And since I can't log into the boxes, how do I know what's happening maybe when I've given an asynchronous event and I'm not sure why it's not popping out of the other side? So our answer for gaining insights into how these functions are behaving is AWS Xray. Today we announced a new service which is designed to help you profile, trace, and understand the topology of your services that are running in the cloud. And while Xray has a lot of uses, I'm going to focus here particularly on its value for serverless applications, which I think are one of the big missing pieces in terms of making serverless really easy to use and serverless applications really easy to diagnose. So with Xray, you can visualize the service call graph of your app. You can see a dynamic service map for what's calling what, allowing you to discover where your dependencies are and also understand what's actually been built in the system. And with that, you can detect hotspots, Places where maybe events aren't moving from place to place as you expected, throttles are occurring, other things are happening that might represent problems that you need to go take action on. Once you've decided where in your broad application topology the problem exists, you can drill in, pinpoint service-specific issues, get timing breakdowns, get all kinds of information about the specific pieces of that dynamic profile, including some of the parts that have previously been somewhat opaque, like dwell times for asynchronous evokes in Lambda, for example. Now, we're really excited by all the improvements that we've been making to developing and diagnosing serverless apps, but we're even more excited by the growing ecosystem around us. We love that so many companies and so many individuals have joined us in the serverless journey, have gotten equally passionate and excited about it, and are offering all kinds of both commercial and open source solutions, from CI/CD approaches to performance monitoring to different kinds of application frameworks. There's a large and growing list of partner offerings. So I want to take a quick look at that. Companies like Twilio have brought their messaging system to Lambda, making it really easy to integrate both business logic running on us with their modern mechanisms for communicating and conversing with both people and machines. Companies like Algorithmia have made all of the different algorithms that they've been able to extract from universities and other places available as part of Lambda through this integration. Zapier offers a way to take enterprise workflows and events from lots of different companies and bring them together, and uses Lambda in that webhook mode in order to be able to do the processing and customization. CloudBees, CodeShip, MyTalk Group, and others provide build and deploy mechanisms for serverless apps. Datadog, Loggly, Splunk, and Sumo Logic give you great ways to do logging, auditing, and performance analysis and monitoring for serverless applications. All of these are available in more information on our partner network. And of course, many of them also are available to get started immediately in blueprints right on the AWS Lambda console. Now, over in the open source world, SAM is in great company. We've got other frameworks that come from AWS themselves, such as Chalice, but also some really great projects out there like Apex, Claudia.js, and Gordon that are making it much easier for people to build different kinds of web application frameworks in order to use Lambda and API Gateway. And Serverless offers a fantastic way to do local testing, configuration, and deployment of Lambda applications. We're also excited to see this list constantly growing, and some of the new projects that are just getting started in domain-specific areas like big data, scientific, and numeric computing are really exciting to us as well. So this is definitely a watch this space. We think over the next year, the open source is just going to blossom in terms of having lots and lots of different domain-rich solutions, all styled on a serverless framework. Now, we talked about how to bring order to sort of the different spatial pieces of a serverless app using SAM. But there's also a potential temporal component to it. We've talked to you in the past about how important it is to keep Lambda functions stateless. So that's part of the core design value. It helps you follow that good design practice, and it enforces that separation between code and storage. So lots of advantages to that. But sometimes you need a little bit of state. For example, you might want to retry a failing function more than the standard number of times. Or maybe you've uploaded an object to S3 and you want to do many different things. You've got an image and you want to create not just one thumbnail, but 10 different kinds of representations and formats. So up to now, it's been a little bit challenging to bring that kind of execution order to what is an inherently stateless function. So everybody remember that class we all took in computer science undergrad and maybe the sophomore year where you learned about state machines? Well, don't worry, we're not going to bore you with math and theory here today. All you need to remember is that we're going to provide you now with a new service that can help you organize multiple Lambda functions or different steps to do your bidding when you care about the order in which they run. So what would you use this for? Well, sometimes you want to be able to control the sequence of two functions. You need to know with certainty that the first function finishes before the next one starts. Or you want to do a fan out. like my example in S3, where you need to have multiple functions run, and you might also need to wait until they're done to take a finalization step. So maybe not just scatter out, but also gather back in. Sometimes you need to retry a function multiple times. Maybe you're even polling for another system that hasn't yet been converted to this event processing style. And you just have to keep trying over and over again until some particular piece of information or some user input is finally received. And then more generally, even though the Lambda functions can only run for 5 minutes each, you might have a broader workflow that can span hours or days or maybe even weeks, even though the individual pieces of it run as Lambda functions. And this is where AWS Step Functions comes in. So it runs state machines in the cloud. It lets you keep that clean separation so that your code stays in the Lambda function, but the choreography, the workflow part of it, is held inside of AWS Step Functions. And there's a really nice, easy-to-use visual designer that you can get to in the console. You can express it in JSON, and of course, you can do it all programmatically as well. This makes it really simple to build, run, and monitor multi-step applications, even when they outlive any individual Lambda function's execution time, supporting thousands of workflows and millions of simultaneous steps. So last year at this time, Lambda was in just 4 regions. Today, Lambda's in 10 regions worldwide, with plans to take it into many more data centers as well, offering you the ability to create applications that live wherever your client and data need to be. But we don't think that's enough. In fact, we want to bring Lambda and Lambda's ease of use and serverless model to every place that our customers need compute power. So today, Werner announced Lambda at the Edge, a preview of our new capability where we can take Lambda functions and push them out into our global points of presence, our 68 POPs today and counting, where you can now run Lambda functions. And in the Lambda and the Edge preview, you'll be able to target CloudFront distribution events. So you'll be able to react to both content retrievals and origin fetches as they occur in those POPs. Now, we've got some restrictions on the amount of capacity during the preview here, but you should expect us to lift that over time and also to broaden out the set of use cases and scenarios that are possible to run in the POPs here. We're really excited to see what customers are going to do with this, and we're really excited to see Lambda going into newer and broader use cases. Now, the POPs are great, but they're still part of our cloud. And as you heard in Andy's keynote yesterday, we're also taking Lambda functions outside of the AWS cloud by enabling them to run on devices. Now, when we created Lambda, we intentionally chose a programming model that could be separated from the underlying infrastructure. And that abstraction has proven super valuable to us, not just in terms of making Lambda itself successful and easy to use and easy to scale, but it also means that we can apply Lambda functions in these new scenarios, such as the newest generation of the AWS Snowball, where you can now run Lambda functions to transform or audit data as you ingest it onto that device and route to the AWS cloud. And we thought that was such a good idea, we said, let's take that framework that we built for the Snowball and expose it and give it out to anybody who wants to use it on their own devices. And that was the origin of Greengrass, this framework that powers Snowball's compute, available to hardware manufacturers now who want to be able to add Lambda and messaging capability to their devices. Because sometimes you've got something, whether you're on a boat or on a tractor or in some other place, where either the responsiveness, low latency, or lack of connectivity to the cloud requires you to be able to do that compute absent the benefit of a data center connection. So look for Lambda functions to start appearing inside your cameras, appliances, thermostats, and everywhere else. 2 years ago, I was on the stage at the Palazzo, introducing a preview of this new thing called Lambda. And my team and I were incredibly passionate and incredibly excited about its potential. But of course, we didn't know if everybody else would be. In the 2 years since then, a huge number of companies a huge number of enterprises have adopted serverless approaches as a core part of their application development. And they've come to depend on Lambda and API Gateway for their most critical business functions. With Lambda and Gateway, with the growing set of other AWS serverless offerings, with our incredible ecosystem and partners, we're enabling customers to innovate more, deliver faster, and lower costs. It's been an amazing ride. But as we like to say at AWS, it is absolutely still day one for serverless. We are only just getting started. Thank you. Enjoy the rest of this incredible program we have for you here at the Mirage today, and go serverless.